This is an AQA GCSE chemistry question. It's from the Trilogy paper 2019 and it's a foundation question. We're going to look predominantly at bonding in this reaction along with some practical skills. So I'm going to recommend you pause as you go through and try each section. Here is part A, part B, part C, part D, part E, and finally part F, a total of 11 marks available. Going through to review, we have got concrete with cement, water and small stones, a mixture designed as a useful product. What do we call something that is a mixture designed as a useful product? It's a key word and definition you need to be familiar with. That one is formulation. On to part B, concrete contains cement. Cement is made by heating a mixture containing silicon dioxide, SiO2. Why does silicon dioxide have a very high melting point? Now, once again, you see this very often in these questions. It's a 2-mark question. You must tick 2 boxes. Always read that question carefully. Now, you have got to be familiar with the fact that silicon dioxide has a giant covalent structure. It's actually very similar to diamond. And once you know that, the rest of this becomes a little bit more straightforward. It has strong covalent bonds. We actually know it's covalent because it's 2 non-metals. That means we can disregard ionic. Because it's a giant covalent with a high melting point, we can disregard weak intermolecular forces. And we also know it's not simple molecular. So that leaves us with the giant structure. On to part C, we've got the apparatus here, looking at how the mass of small stones in concrete affects the strength of a concrete beam. Student added weights until the concrete beam broke. Which is the control variable? Well, the control variable here of the options that we have is the length of the concrete beam. If it was longer, moving into physics for a bit, we would have a greater moment. It would be a far greater impact. It would snap more easily on a longer concrete beam. In terms of the independent variable, we're looking at what it is that we're changing, and that's the mass of small stones in the concrete that we are testing. On to part D, plotting a graph. Obviously slightly more difficult for you to do if you're doing it on video, but we will go through and I've plotted my points there and we've got quite a nice smooth curve. Always take the time to plot points carefully because they're easy marks to pick up. The line of best fit, we're continuing the curve around, and from there we have got a question about what mass of small stones needed to make the strongest concrete. We're going to use the graph to answer it. It would be 1500 grams. The reason for that? That's the highest point on the graph. That's the highest weight needed to break the concrete beam in newtons. And finally, we have another graph here. Student B did the same experiment, but actually didn't do it as well. How could they improve it? They did 500 grams and 1000 grams and plotted that graph. Well, actually, it would have been better if they'd taken more measurements, if they'd done smaller increments, maybe at 200 and 400 and 600 and 800 and 1000, for example. And that takes us to the end of the question.